Alright guys, so this is your last video for chemistry, and this video is called Chemical Equations. So what happens if you are presented with a word problem that happens to include a chemical reaction? Well, we talked about in the last video that each chemical symbol represents a letter or represents a particular element, and when you combine elements together to make a compound, you end up with a chemical formula. And you learned in the last video about subscripts and about coefficients. Well, what happens if you're presented with this word problem that just has the chemical equations or chemical formulas and chemical symbols for the particular elements? Well, you end up with a chemical equation. So what is a chemical equation? Well, they are like sentences. You put letters together to make words, and then you put words together to make sentences. And so you put chemical symbols together to make formulas, and then chemical formulas together in a specific way to make sentences. Just like in English, there has to be a noun and there has to be a verb, and you include adjectives and adverbs and punctuation. Well, a chemical equation is a lot like that. There is an order to how the equation is written. Every chemical reaction has substances that you begin with. Those substances are called reactants, and you'll notice that I put them in a red color. That's going to be for a particular reason that we'll come to later. And ending the substances are always going to be your products. What comes out of the chemical reaction or the chemical equation? The equation is always read from left to right. Just like you read a textbook or you read a story from left to right, you also read a chemical equation from left to right. So here's a very simple chemical equation. 2 molecules of H2 or hydrogen gas combine together with 1 molecule of oxygen gas to give us 2 molecules of water, or 2H2 plus O2 yields 2H2O. This is just a simple equation to show us that hydrogen gas and oxygen gas are going to chemically combine to form liquid water. You'll notice that there is this arrow. The arrow is always going to go from left to right. It's always going to point to the right. The arrow means yields or makes or reacts or breaks into. So in a word problem or something that you're presented with that would be a chemical reaction on paper, these are the possibilities that that arrow could represent. It's just like the equal sign in a math equation. H2 and O2 are the reactants, whereas H2O is the product. So I'm going to underline the reactants, and I'm going to underline the products. And every time the reactants are on the left and products are always on the right. Well, just like in physics, where we had Newton's laws of motion that told us the way that things are going to move or not going to move and how they're going to change their motion, we also have a law in chemistry called the law of conservation of mass. In every chemical reaction, just like the ones that we did last week in our chemical lab, the amount and the types of matter that we start with or begin with must equal the amount and types of matter that we end with. We had calcium chloride and sodium bicarbonate. That's what we began with. What we ended with was some carbon dioxide gas that puffed the bag up. Well, where did that carbon come from in the end to make carbon dioxide? It came from the sodium bicarbonate or the baking soda. So the law basically says matter cannot be created nor destroyed. So this is where counting atoms is going to come in handy, because I don't get to see the evidence, I simply look at the numbers. So let's go back to our simple equation of hydrogen gas plus oxygen gas giving us water molecules. So I simply count 2 atoms of hydrogen, but notice I have a coefficient. So it's 2 times 2 to give me 4 atoms of hydrogen on my left side. 1 times 2 to give me 2 atoms of oxygen on the left. I do the exact same thing on the right side, 2 atoms of hydrogen times 2, and then 2 atoms of oxygen times 1 coefficient to give me 2. I find that I have a total of 6 atoms on the left for my reactants and 6 atoms on the right for my products. So I would say that this chemical reaction follows LCOM, and that's a wrap.